Alright guys, welcome back to Underground Science, and in this video we're going to continue where we left off in the intracellular erythrocyte reactions part 2 video. Alright, so let's go and get started. So we just have to talk about what happens to the carbon dioxide, right? So we know that we talked about how oxygen diffused in, and then how we talked about shortly about the Le Chatelier's principle, how because so much oxygen is diffusing in from the alveoli into the deoxygenated red blood cell, that the reaction starts to shift backwards, all right, because we have to balance out the reaction as a whole, right? So as our oxygen concentration starts to go up, the whole reaction starts to shift to the left, and now we have oxygen competition. If we're looking at this reaction, we have oxygen competition with the hydrogen cation bounded to the hemoglobin. Then what happens is that we make oxyhemoglobin again and kick off the hydrogen cation. And then we said that in this reaction, right, we have oxygen again competing with mainly the carbaminohemoglobin, which is just carbon dioxide bounded to hemoglobin. We end up making again oxyhemoglobin, which is just oxygen bounded to hemoglobin, and we kick off the CO2. And so those are the main reactions, right, that happen because of Le Chatelier's principle. Now what we're going to see is how the CO2, how we breathe out CO2, right, because we're breathing out CO2 every time we exhale. So what happens now, so let's go and just jump right into it. Shouldn't be that long of a video. So what happens is the CO2 now that is in the product side, so that we'll see here, remember CO2 is kicked off because oxygen won the battle, right? And so what happens is that now since CO2 is free, right, in the red blood cell, because again we have high concentration of carbon dioxide in this red blood cell at this moment, right, we're going to have diffusion of carbon dioxide from high to low concentration. So this carbon dioxide is going to be like, bro, I'm out, right? I'm dipping. And he leaves and he enters the alveoli where you breathe all the CO2 out, right? So that's not the only part where CO2 is coming from. Remember, the main way is bicarb. Remember, when we're talking about in our part 1 and 2 video, near the muscle cell, we said that when CO2 combines with water, we form carbonic acid. And when carbonic acid dissociates, it dissociates into a hydrogen cation and a bicarb. This is happening near the muscle cell. Then bicarb, we said, dissociates or dissolves into the plasma, right? Most of the bicarb dissolves into the plasma, and then we said that the H plus here then goes on to compete with oxyhemoglobin, right? This is all happening inside the red blood cell, okay, but near the muscle cell, not here. All right, what happens here near the alveoli is that the carbonic or the bicarb, right, the bicarbonate anion comes into the red blood cell now, okay, from the plasma because of all this free hydrogen cations that the oxygen competed with, right, because of Le Chatelier's principle. So what's going to happen now is that let me go ahead and just, oops, sorry about that. Let me go ahead and draw a continuation of this red blood cell. Right, so let me just go and draw a little continuation, and we still have our alveoli here, right? So we still have our alveoli here. And again, everything's the same, guys. I didn't change anything. This red blood cell is still inside the pulmonary capillary near the lungs. But what's going to be different now is that we're going to see how, so remember, this is all the plasma, right? Still in the pulmonary capillary. And we said now we have our bicarb that we initially dissolved near the muscle into the plasma. Now it's coming back into the red blood cell. So why is that? Because of all the free hydrogen cations that we have because of the competition that oxygen put up with, right? Oxygen right here, it competed with the hydrogen cations that were bound to hemoglobin and freed it, right? So the hydrogen cations got kicked off and we got oxyhemoglobin. So what's going to happen now is these hydrogen cations are going to come and are going to react with the bicarb that's coming in from the plasma into the red blood cell. What is that going to lead to? Well, that's going to lead to the formation of carbonic acid. All right, so if we come here and we look at the formation of carbonic acid, which is right here, right? When carbonic acid forms, we said that it would also dissociate into H2O and CO2, right? So, but how? We need carbonic anhydrase. So then carbonic acid comes here and it's like, all right, bro, I have to dissociate. So where's my friend? I need carbonic anhydrase. So carbonic anhydrase is like, I got you, I'm right here, right? Carbonic anhydrase is like, yo, I'm here, right? So he stimulates this reaction from carbonic acid dissociating into CO2 and water. So now you guys see how how bicarb was indirectly the main carrier of CO2 all this time, from the muscle cell all the way to the lungs. And it was all the time in the plasma, right? Most of the bicarb. How? Because it was indirect, right? First, it had to convert into carbonic acid. Then, via carbonic anhydrase, it dissociated into CO2, which is what we're trying to discuss here, and water. So we have a bunch of CO2 coming out now because of all the bicarb that's dissociating into the red blood cell, and that's reacting with all the free hydrogen cations via oxygen competition, right here, with the hydrogen cation bound to the hemoglobin. So we have a bunch of CO2 again forming here, and this CO2 again will go to the lungs, right? So it's going to draw this all the way, and it's going to the lungs, and we'll breathe this out also, right, as waste. And so that's pretty much it. That's how CO2, it makes it from the red blood cell to the lungs. So first, let's just do a quick review. So first we shift the reaction backwards because of the extra oxygen, freeing the carbon dioxide out, and we bound the oxygen again to the hemoglobin, making oxyhemoglobin. Then this free carbon dioxide can go into the alveoli, right? It got freed from the carbaminohemoglobin. Then we said the main way is that bicarb starts coming into the red blood cell because of all these free hydrogen cations. And then these hydrogen cations react with the bicarb, making carbonic acid. Then carbonic acid dissociates into water and CO2 via carbonic anhydrase. Then the CO2 then also makes its way into the alveoli, right? So those are the main ways we said we carry carbon dioxide through the blood is through the bicarbonate anion, and through carbaminohemoglobin, and also some free CO2 molecules that are just plainly dissolved into the blood or into the blood plasma, right? But not much. And so that's pretty much it, guys. So all these reactions happen. So whenever we talk about the blood coming into the pulmonary capillaries, then CO2 dissolving or diffusing into the alveoli, and O2 dissolving from the alveoli into the pulmonary capillaries, becoming a venule, right? We're just saying that, but what's actually happening is all of this, all right? So it's actually pretty cool. It's pretty fascinating. That's what I want to get through in this video. I hope this video made sense to you guys. So stay tuned for my future videos. We'll talk about more cool topics about biochem, chemistry, and physics. Make sure to hit that notification bell, like and subscribe, and see you guys later, and stay safe.